Okay, very good morning, one and all. So
Yes,
last class, yeah, last class we discussed some truth tables concept, and what is a conjunction, disjunction, conditional, biconditional. These are the concepts we discussed in the last class, Summer. So may I know, first of all, we want to know what is condition, what is a conditional, what is biconditional, what is conjunction, what is a disjunction. Okay, already we discussed, right? Disjunction, any one statement is true, then the compound statement is true. That is a disjunction, right? And coming to this conjunction, if any one statement is false, then the compound statement is false. So that is a conjunction. Okay, now coming to conditional. The conditional first statement is true and the second statement is false, then the compound statement is false. Otherwise, it is a true. Okay, that is a conditional. Coming to this biconditional, if the two statements P Q, the two statements either true or false. Okay, the two statements either true or false, then the compound statement is a true, otherwise it is a false, right? So these are the concepts we discussed in the last classes. So okay, yes, here it is there. Yes, everyone please observe the two statements P comma Q, that both the statements having the same truth values, then the compound statement is true. Okay, otherwise it is a false. So based on that we discussed some examples in last class. So this is for example P comma Q, P and Q, negation P and Q. And one more example by using 8 possibilities, that means 3 statements 2 power 3, that is equal to 8 possibilities we discussed in the last class. So most of the students completed this task. So who are not completed, so please make it practice well, make it practice again and again, because if you did a small mistake, the total 10 marks we lost. That is the problem here in this truth table summa. So now we are moving to this one more concept, that is exclusive R. They are not asking this question from last 2 to 3 years, but we want to know what is an exclusive R basically. Okay, yes, just either P is true or Q is true, but not both. Then the compound statement is either P is true, either P is true or Q is true. Okay, then the compound statement is true. Otherwise, it is a false sign. Okay, but not both. But not both. See, everyone observe. But not both. A little bit here it is a small relation between conditional and exclusive or conditional. See that here, what is a conditional? First statement is true, second statement is false, then the compound statement is false. Otherwise, it is a true, right? See that here.
opposite to biconditional, sir.
Yes, yes. Very good, very good, very good, very good. Opposite to biconditional. Opposite to biconditional. Yes. See that here, this is a biconditional. True, false, false, true, and false, true, true, false. Exact opposite to biconditional. Okay. So I want to say actually conditional, then after biconditional, I want to come like that. Okay, you mentioned biconditional, very good answer. Okay, guys. It's opposite to biconditional. Okay, now, how many of you remember what is an equivalent of P implies Q? Equivalent of P implies Q. Guys, anyone? Please respond. What it is an equivalent of P?
Negation
Yes, very good. Negation?
Q implies P.
No.
P or Q, sir.
Very good, very good, very good. Someone already mentioned here in the chat box negation PRQ 527 and 505. Very good answer, someone. So negation PRQ, that is an equivalent end. Okay, I want to mention in all the meetings. Yes. Uh, so everyone, please must make should observe this point here. Yes. Negation PRQ. Negation PRQ. This is a equivalence. Sorry, I want to mention once again here, guys. It's an equivalence of P implies Q. It is an equivalence of P implies Q1. Yes. What about the by implication? Otherwise, by conditional. Anyone, please? What is the equivalence in? Anyone, please respond. What is an equivalence of biconditional? Last class we discussed. Yes, sir. Very good answer. 527. P implies Q and Q implies P. 527. 527. 527. 527. 527. 527. 527. 527. 527. 527. 527. 527. 527. 527. 527. 527. 527. 527. 527. 527. 527. 527. 527. 527. 527. 527. 527. 527. 527. 527. 527. 527. 527. 527. 527. 527. 527. 527. 527. 527. 527. 527. 527. 527. 527. 527. 527. 527. 527. 527. 527. 527. 527. 527. 527. 527. 527. 527. 527. 527. 527. 527. 527. 527. 527. 527. 527. 527. 527. 527. 527. 527. 527. 527. 527. 527. 527. 527. 527. 527. 527. 527. 527. 527. 527. 527. 527. 527. Very good answer, 527. Anyone, please respond till. Still, any responses? Only 527 has been responded. It's a wrong answer, 505. Yes. Very good answer. Yes, yes. Very good answers. So this is the answer. So sorry. So this is the answer finally. Why it is coming like this? Not everyone. Yes. Yes, very good. Thank you, 547. P implies Q. Sorry, I'm wrong answer. 547. P implies Q and Q implies P. 547, it's a wrong answer. P is the answer is in P implies Q and Q implies P. 552, very good answer. So first one is wrong answer, 552. Second one is a very good answer. P implies Q and Q implies P. And 523, very good answer. P implies Q and Q implies P. 508 also very good answer. 527. Yes. Okay, fine. So final the answer is an P implies Q and Q implies P. That is an equivalence of biconditional, or if and only if P, if and only if Q. How to read out P implies Q? Anyone please? How to read out P implies Q? Yes, sir. Very good. 527. If P, then Q. It's better to unmute yourself and tell me the answer, because actually rest of all also will listen that word, the statement somehow, if possible. I request, if you know that answers, if I'm asking, so please respond, unmute yourself and tell me the answer. Yes, P only if Q. Very good, 505. If P, then Q. P only if Q. Okay, P implies Q. You can mention like that. Okay, very good answers, guys. So thanks for your responses. So now, as already I mentioned, it's an exclusive R. Yes, a very good 501. Yes, this is an exclusive R, exact opposite to biconditional statement. Exact opposite to biconditional. So now we are moving to NAND gate. So simply I mention here. See that everyone observe, it's a NAND gate, not plus N. We want to mention here, it's a not plus and not plus N. That is we call it a NAND gate in term. That is we call it a NAND gate. So not plus end. That's why they mention here not bracket open P and Q. P and Q. That's a not plus end. So same as not, same as not. Here also same thing here. Here also same thing. Okay. This is a NOR symbol. Everyone please observe. So NAND, this is a NAND symbol. You can mention like that also, no props. Okay, and NOR, this is the NOR symbol. Sometimes actually in examination, in exam papers, actually the symbols are looking like here, upper arrow and down arrow. So don't confuse here. Upper arrow means is an AND gate, and down arrow means it is a NOR gate. And not plus R, it's a negation. See that here, PRQ we know that is a true, 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 false. See that here, exact opposite, false, 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 true. Here, that P, let P and Q be two statements, then the compound statement P nor Q, this is a nor Q, is equal to negation of P R Q. Negation of P R Q. So two statements, that's why four possibilities are there. We know what is the P R Q. Any one statement is true, then the compound statement is true, otherwise it is a false. And coming to the NOR, it's a negation of PRQ. That's why negation of true, it is a false. Negation of true, it is a false. Negation of true, it is a false. Negation of false, it is a true, guys. So these are the connectives we have. Okay, what are the total, what are the connectives we discussed till now? One is, first of all, negation. Okay, yes, sir. Yes, sir. Let me know here, please, guys. Everyone, please respond. What are the connectives we discussed till now? Negation.
Conjunction, disjunction,
Okay, conjunction, disjunction. Others also, please respond.
conditional, biconditional,
Okay, conditional, biconditional.
NAND and OR,
Okay, conditional, biconditional.
XOR,
Okay, yes, XOR, exclusive R. NAND gate, and NOR gate. Total 8 connectivities we discussed in the class 2 memo, and some examples also we performed. Okay, parallelly. Yes, guys. So now we are moving to next one is a well-formed formulas. So most important one, well-formed formulas. What is the importance of well-formed formulas? See that here the meaning is in well, excellent. That means we have to follow while we are finding while we are whatever the compound statements are there, we have to follow some rules and regulations. What are the rules and regulations? How can you say that a statement is a well-formed statement or well-formed formula? Okay, statements represented in symbolic forms, that is a P implies Q, A implies B, A and B, A are B, and so on like that here, right? Okay, which cannot be interrupted in more than one way are called well-formed formulas. So expressions must and should it consisting of statements, that means prepositions are variables P comma Q, parenthesis. So see that here. So every time I am going to mention, please everyone observe in the chat box. See, if P implies Q, see that here. Already I mentioned here 946, 946 I mentioned here. P implies Q, P implies Q, and Q implies P. That is we call it a well-formed formula. So whatever the compound statement is, the compound statement must and should be closed with the parenthesis. Closed with the parenthesis. So that is we call it a well-formed formulas. Each and every statement must and should be connected with some connection symbol, either and or else negation, or else something conditional, or else biconditional. So that type of statements only we call it a well-formed formula. See, simply I mention here one example to you. One second. Okay, so a simple example of well-formed formulas, like here P and Q. It's a well-formed formula. If I'm having the two statements are there, then this is one example of well-formed formula. A simple here one more P R Q, and again this is also is a well-formed formula. Okay, and one more. So P implies Q. This is also one of the well-formed formula. Well-formed formula. And one more, for example. Okay, see that here. P implies Q. Okay, and Q implies P. Okay, and this is also one of the well-formed formula, like that here. Okay, so one compound statement and second compound statement must should be connected with the some connectivity. That is the concept here I mention here. Everyone please observe. Statements. So we have some different types of statements are that P comma Q, P comma Q, P comma Q. Some statements are variables are there. Parentheses. We mentioned some parentheses, the combinations, and each and every statement. See that here. So two statements I'm having. How we connect in the two statements? By using one of any one of the connectivity, and or implication, or something else, whatever it is you can take. Otherwise, here I want to take one more. So negation PRQ, like that here, parenthesis and connecting the symbols. So this is examples of well-formed formulas. Statements represented in symbolic forms, we know that is in the first class I mentioned. So we want to represent our statements in symbolic form. What are the symbolic forms? A, B, C, P, Q, R, X, Y, Z, which cannot be interrupted in more than one way are called well-formed formulas. Okay, so this is the expression consisting of statements, parenthesis, connection symbols. Okay, yes. If A and B are well-formed formulas, I mentioned P comma Q comma. In the example they mention here, A and B are well-formed formulas. So A and B, I mentioned same thing here. A R B, I mentioned P R Q, A implies B, and A if and only if B are well-formed formulas. Are well-formed formulas. Okay. And now coming to the most important one, it is a laws of logic. So already we discussed earlier, and what are the laws of logic? Yes. So double negation. So negation of negation P equivalent to P. Yesterday I shared this document to you, Amma. So please go through that document if you want, and please be prepared well. Okay. For any preposition P, negation of negation P equal to P. It is a double negation law. It is a double negation law. And now P implies Q is a loss of equivalence and a negation P or Q, and P implies Q. What is an equivalent of P implies Q? Negation Q or negation P. Negation Q, sorry, negation Q implies negation P. It is the equivalent of P implies Q only. Okay, otherwise one more it is there. Okay, so one more it is this is the negation PRQ. Both are same. Anyway, we can mention no problem. But we have to mention it is a loss of implication. It is a loss of contrapositive. Loss of contrapositive reversing. Okay, we'll discuss about it contrapositive and some others. Yes. Now idempotent law. P R P equal to P, P and P equal to P. Next, identity law. P and T equal to P, P R F equal to P. Laws of complementation, inverse laws. P or negation P equal to true. Okay, P or negation P is equal to true. A simple one like here, P and negation P. Okay, so already we know what are the symbols we want. It's only one statement it is there. That's why two possibilities are there, true, comma, false. So coming to next, what is a negation here? False. And what is a negation here? It is a true. Now coming to next one is in P or negation P. P or negation P. Well formed formula we learn now. So that's why I want to mention like this. Okay. Now, what is answer here, guys? It's a true, and again it is a true. Again it is a true. So that's why they mention here P or negation P equal to true or not. And coming to
Sir,
the yes.
identity loss of చెప్పండి.
One okay, sure. P and after this I will tell you. Okay. Okay, P and negation P. Okay, P and negation P. We know that is an it's a false, and it is a false.
False.
Okay, so that's why they mention here P and negation P equal to false. Okay, fine, guys. Now someone asked me this. Yeah. One second. Okay, see that here. If any identity loss. Okay, if I'm taking any one example, like it's a P is a one statement, right? P is a one statement, and so I want to take it's a P. It is in a one. P it is in a one. Mathematically, how to represent an end, guys? Mathematically, how to represent an end operation?
Multiplication.
Multiplication. Very good answer. The true is in binary format. How we represent some true equal to
1.
so that means it equal to 1. What is the answer here, guys? So P means what? Why mention P? So it is an identity law. And now coming to the same thing here, 1 and R, how we are going to represent a plus, and false means it is in 0, that is in equal to 1. So that's why in identity law they mention here P and T equal to P, P or F equal to P on top. P or F equal to P. Okay, guys, fine.
Yes, sir.
Okay, right. So like that here we have lots of concepts. We have domination law. So P R T equal to true, P and F equal to false. And coming to this, already we know what is a commutative law, what is an absorption law, what is a De Morgan's law. But I want to read out one by one, guys. So I'm not okay. One person, yeah, yes. Okay, so any one person, please read out. Yes, I will ask one person who are in that. Yes. Roll number 527. Roll number 527.
Yes, sir.
So please read out commutative law. Please read out commutative law.
Sir, am I audible?
Yeah, you're audible, Amma. Please.
Yes. P or Q is equals to Q or P, or second one is P and Q is equals to Q and P.
Okay. It's not an equal to. It's an equivalent analysis.
Yes, sir.
Yes. P or Q is an equivalent to Q or P. P and Q equivalent to Q and P. Okay.
Okay, sir.
Okay, fine. Next, the 528. Roll number 528. Roll number 528.
Yes, sir.
Okay. Please read out absorption law.
P or P
Yes.
and Q equivalent to P.
Okay. Very good.
P and P or Q equivalent to P.
Yes. Very good. So here, each and every laws, commutative law, association law, or absorption law, or distribution law, whatever the laws we have, okay, it is possible to construct a truth table each and every one of them. Commutative laws, absorption laws, demograph laws, double negation law, whatever it is. Okay. Yes. Next, 539. Roll number 539. Roll number 539. 539. Are you there or not? Roll number 539. Roll number 539. Last call. Okay, ma. Thank you. Put it in waiting. I'm putting in waiting room. Okay, next. 550. Roll number 550. Roll number 550. 550. I repeat, roll number 550. No answer. Okay. Roll number 505.
Yes, sir.
Okay. Yes, please read out here De Morgan's law. De Morgan's law.
Negation of P or Q equivalent to negation P and negation Q.
Okay.
Negation of P and Q equivalent to negation of P or negation of Q.
Okay, very good. Yes, everyone please observe in De Morgan's law. It's a very good concept. Just we are applying the negation to inside and we are applying the negation to each and every statement. First of all, negation P. What is the negation of R? Negation of R is an
And
and that's why they mention here negation P and negation Q. And like same thing here, exact opposite, negation of P and Q, which is an equivalent to negation P or negation Q on term, negation Q. Now, so already we know, everyone knows about this one is an association law, distribution law, but we want to ask someone. Yes. Roll number 536.
Yes, sir.
Okay. Yeah. So please read out association and distribution law.
P or Q or R is equivalent to P or Q or R.
Yes.
P and Q or R is equivalent to P and Q and R.
Okay. Okay. Coming to distribution law.
Distribution law.
Yes.
P or Q and R is equivalent to P or Q and P or R.
Yes.
P and Q or R is equivalent to P and Q or P and R.
Very good. Very good. Okay. So how many of you observed the difference between association and distribution law? Are you observed any differences associative and distribution law? Guys, anyone please respond. Guys, anyone please respond. Are you observed any point association and distribution law?
Sir, in associative, we have two same connectives like P
Very well.
or
Excellent.
Q or R.
Excellent, excellent, excellent. Yes. In association law, so we use single connectivity, either R or NM. Please observe everyone. Okay. And see that here. Here order is not an important here. Order is not an important. See that here P R Q R R. You can take it as an P R Q R R. Order is not an important in associative law. Okay. And here also P and Q and R, which is unequivalent to P and Q and R and R. Coming to the distribution law, order is important. And see that here, everyone observe, it's a two different symbols. We want to distribution. We want to distribute something. That's why PRQ, PRQ, and PRR, PRR. Like this here, that is the difference between, very good answer, ma. That is the differentiation among associative law and distribution laws. Okay, already we know it is a condition law. So we already learned in the previously P implies Q, which is an equivalent to negation P R Q ani. So this one is also we already learned P if and only if Q, P implies Q and Q implies P. That's already we learned in the previous. Okay, now so most important one, it is in three statements we have. So I want to tell you here. Okay, that is converse, inverse, and contra positive. Contra positive of implication. Contra positive of implication. Not all. Not all. Okay. Converse, inverse, and contra positive of implication. Implication. Okay. First of all, so I want to take it as in one implication. P implies Q. P implies Q. Now we want to write it down here. So here we have two possibilities are there. P implies Q, it is there, implication, and next one is in Q implies P, it is there. Q implies P, it is there. Now, first of all, converse. Okay, now I want to take it as in converse. Simply we call it as an reverse, not inverse. Everyone observe. Reverse, converse. Okay. Inverse. Okay. It is an exact opposite term. Exact opposite. Next, contrapositive. You cannot say anything here, so it's, but it is a contrapositive. Everyone please observe, it's a 2 marks or else 3 marks question. Okay, converse, inverse, and contrapositive. So I mentioned, see that here first two already easy to tell you. Converse, it is a reverse of implication, that is an, so my statement is an P implies Q. My statement which is an P implies Q. And simply what is the reverse here, guys? It is a Q implies P. It's a Q implies P. And if you want to mention like that, it's better option. Okay, next one is what is an exact opposite to P implies Q? What is a exact opposite of P? It's a negation P, right? So negation P implies, we cannot mention negation exact opposite to implication. Implication is must and should be there. Okay. Okay, negation Q. Negation P implies negation Q. So it is a well-formed formula right now. Yes. Now contrapositive. Now it is in a contrapositive. What is the answer for this one? Is in contrapositive. Any guesses, guys?
Sir, negation Q implies negation P.
Yes, sir. Exact opposite to it's a converse. It's an exact opposite to conversion. Very good answer. Yes. What is an exact opposite of converse? So already we know that is negation Q implies, sorry, negation P. Okay. Okay. So this is an, I'll check. Okay, fine, it's working. Okay, guys. So this is the information of converse, inverse, and contrapositive of implication. First of all, P implies Q. P implies Q. What is a converse? Simply we want to say it is a reversant. So that is an Q implies P. And next one is an inverse. It is an opposite to that P implies Q. Opposite to P implies Q. Negation P implies negation Q. And next one is in contrapositive, exact opposite to that. Not exact, I don't want to mention here. It's not looking good. Okay, opposite to converse, opposite to converse. A simple one is I mentioned here, negation Q implies negation P. So this is an information about converse, inverse, and contrapositive. Converse, inverse, and contrapositive. Yes, I want to give you one example, guys. P, it rained, for example. Okay, and Q, the weather is good. Okay, now tell me what is the converse, guys? Hello. First of all, what is a P implies Q for this example? Yes. Anyone please respond? Guys, anyone please respond? Okay, very good answer. 507 and 536. First of all, P implies Q. What it's an P implies Q? If it rains, then the weather is good. Very good answer, Amma. If it rains, then the weather is good. Then weather is good, then the weather is good, no problem. Then weather is good. Okay, now this is a P implies Q. Everyone please observe. It rained. Example P, it rained. Q, the weather is good. P implies Q. If it rains, then the weather is good. Then the weather is good. Now we are moving to that. What is a converse? What is a converse, guys? If the weather is good, if the weather is good,
It rains.
okay, very good answer. So simply we want to write here, when the weather is good, then it has rained. Then it has rained. As simple. So not exactly we want to mention anywhere, no problem, but we want to mention like no, not like that. Converse slow. See, Q implies P, it is there. Okay, contrapositive. Very good, very good. Inverse also you mentioned. Very good. 508. Inverse. Very good. If the weather is if mandatory. Inverse lo kuda if mandatory. If the weather negation P kada. What is the negation P? Inverse. What is the inverse? Inverse. Yes. If it not rains, when? Then the weather is not good. Very good answer. Okay. If is mandatory, otherwise you can mention like that. Converse. Simply, we want to mention like that. If the weather is good, then it has rained. Okay. And next, contrapositive. What is this one? Is in contrapositive. Yes, someone mentioned already. What is this? Contrapositive negation Q implies negation P. Exact opposite to conversion. Exact opposite to, if the weather is not good, if the weather is not good, then it did not rain today. Yes, very good. If the weather is not good, then it did not rain today. Very good. Like, so if is mandatory, okay, otherwise equivalent, otherwise it is an equivalent. Okay, so like when it rains, when it rains, the weather is good. When the weather is good, it implies that it has rain. Whatever it is, you can mention like exact opposites. We need to mention. Yes. Okay. Okay. I'll give one example, guys. I'll give one example. Please try this, everyone. So almost 10:20. So today we are going to close this converse, inverse, and contrapositive. I'll give 2 to 3 examples, guys, and everyone please try this example. Okay. That is first of all. So the statement P is okay. India is a country. India is a country, and Q, LG is a good company. Okay, so everyone please write the converse, inverse, and contrapositive for the following statement number. This is an example 1. Okay, and now coming to this one is an example number 2. Okay, if two angles in a triangle, if two angles in a triangle are equal, then the triangle is isosceles. Okay, guys. So 2 examples are there. 10 more minutes we have. So everyone please complete these 2 examples at a time and send me. Then I'll take attendance.